Hi everybody, Rachel here. I am presenting on what I learned from CIT260, which is a lot. Hopefully I can get through it all. So I first want to start off by explaining the difference between static class variables and non-static variables. So the difference is you can use a static variable anywhere within a class. So in our program that we made, we used a static variable in byland. So we did create it within here. We created a public static int byland within a function. However, we could actually use this particular uh, integer anywhere within the class, but we didn't because we didn't have another function within that class. So go back. So a non-static variable can only be used in which the function it is called. So in this example, we have an int row and an int column, or a max row, max column, and we can only use it in this create map because it's not a static variable. So in our other, let me show you really quick. In the rest of map control, so we have that max row and max column, where we have other functions like move player to starting location and just move player. We actually can't use that without declaring another int or column and row like we did here, because it's not a static variable. It can't be used throughout all of the classes. So this is an example of using a static variable in a different setting. I just wanted to include this. So in this, they declared in their class public static int barcode. And then in public static int in this different function, they can actually return the barcode, or they can reset the barcode to an int value. Like there's so many different things that you can do with a static that you can't do without redeclaring. So if this hadn't have been a static, then I would have to redeclare, all right, barcode is an int, and redeclare all that in order to do this same thing. So it kind of makes your life a lot easier in some cases. So arrays, um, there's three different types of arrays, but I'm going to first talk about just regular old arrays. Arrays are objects and they can be used to reference length or their length. They can be static, so they can be referenced throughout multiple functions in the same class, and they must be an integer. They can't be a long or a short. So in our program, we definitely used an array to create the map. So right here, we're creating our array and then we're putting the values in. You do have to have a set amount in your array for just a regular array. You can't just declare it an array and have it not have a certain amount, because arrays they're always going to have the same amounts. You can't add or change them at all. So an array list actually can be added or changed. So the specified amount isn't more important like it is in just a regular array. So right here, they're calling the array list, and then they're adding elements into the array. You can also delete elements out of the array, as shown right here. Array lists are ever changing. They're if you need to change the information in your array, which we did not actually use in our program because we felt that an array or a unum is going to be our better option there. So and Unum, the amounts are fixed and you have to know all of the values at the time that you compile. So A good example is in car. They declare this car a unum. So Lamborghini, BMW, Audi, Fiat, Honda, all of those are part of the unum, and we know that it's a fixed length and they're all the same value when we compile. We know that. So this is really good for stuff like this. We're like, okay, case one, we chose Lamborghini. It also works really well for getting that input because we had a lot of different menus where we wanted them to choose their options. So learn more about tithing, learn more about land, learn more about gameplay, all of that. So this is actually a really good place to declare a unum and say inputs and have all of those different cases saying that same thing. So let's go to our map control. This is where we used our array in our program is right here. And I kind of touched on it a little bit already, but we've got our location and where we declare our array. And then we kind of iterate through the array where we say, all right, our as long as our row is less than our max row, you can keep going over rows. And then we can get our location by saying, all right, 0, 1, we're in the 0 column, first row, and that's gonna be able to iterate through. As far as the array list, like I said, we didn't actually use one, but in our unum, we could have used one. We didn't, but we could have easily used one for some of the get inputs. So for instance, for our help menu, learn more about tithing, learn more about land. We could have used a unum and been like, all right, unum, actions, all of that, and use that as our cases. And that would have been a perfect example of a unum. All right, so throwing and catching runtime errors. So I first want to touch on, because I was really confused about this when I first read about throwing and catching runtime errors. So the difference between a runtime error and just a regular error in your program is regular errors in your program won't let you compile, and therefore you can't always run your program with just a regular error. With a runtime error, you can run your program, but it's not always going to work correctly unless you address these problems. So, for instance, right here, if someone were to enter less than 0%, there's no such thing as less than 0%. And so we would throw a new error saying, you need to enter a different value. Your percentage can't be less than 0. Same with greater than 0. And we did that with like tithing. We did that with, let's see, let's go to it really quick. So we did tons of errors. We did that for buy land. We did that for game control. We did that for harvest time. Population. We really needed to be able to catch the errors in most of these different things because if they entered something that was going to be wrong, we needed to be able to say, that doesn't work. Or your population can't be larger than 300. And so we needed to be able to throw and catch those errors just in case they entered something that was not going to work. So the difference between a byte stream and a character stream. So a byte stream is going to be an 8-bit stream. So you can use file in stream or out stream. Or file, I'm so sorry, file input stream and file output stream. I said that wrong. So right here, we're using file input stream in. So that's our variable and it equals null. So our variable is in. And then we're going to check and see, all right, in less than or greater than null, do this. Close this program, read it in, or whatever you're wanting to do. Or you can have a character stream which is going to be a 16-bit Unicode input and output. So it's going to be a file reader and file writer. So really the biggest difference on when you would use these are Unicode will actually, or sorry, the byte stream will actually work for most cases. However, it's not really a very good choice to use for reading in text files, because if there are large files of text, a byte system isn't necessarily going to do what you need at the speed that you want it to do at. It takes a lot longer for a byte stream to handle those same things. So in our program, we actually did that in our map control. And we actually did it in early risers as well. I want to show you early risers, but we did it in our map control as well. I believe it was our map control. Maybe I'm just saying that. So right here, we actually used a byte stream because that's just what we decided to use. So we used print writer and buffer reader as our variables. Oh, and look at that. They are actually static class variables too. Look at that. Very cool. So we learned about those earlier. This can be used anywhere in the class, and that's why they're declared right after early risers, is because now I can use these in any one of these functions. So I can use it in any one of these. All right, back to what I was saying. We used a byte stream, and we declared it here at the top. And now what we're doing is we're actually trying to read in a file. So we're getting a message. If it's not there, or if we can't find it, if it's nothing, we're gonna close out the program. So makes sense. And then we're gonna do something very similar for save game. Maybe that's in game control. Yes, it is. Okay, that's what I thought. So we're gonna do something very similar with our saving game, because we need to know if they save their game, we need to pick it up. So we're going to use our file stream to read in that information. Again, we did use a byte stream. We did not use a character stream, but we're only trying to figure out if they saved their game or not. We're not actually reading in large quantities of text. So that's why that was a good option there. All right, so the way that our game is set up, I just want to explain this really quickly. I'll hit run and pull up that screen really quick. Oh, there we go. So this is our game. I'm going to start by entering my name, and it's going to say, "Welcome, Rachel, to the city of Erin." The way that we set up our game to be easily winnable or losable is a point system. So if we start a new game, we can move around the map. So let's say display map is 7. So this is our map. We're currently at inventory 1, which shows by the asterisks. We can move to the left, right, up, down, anywhere within this map. At every place, it's actually going to ask us a question. So if we move our player, it's going to say, oh, not that. It's going to say, I have a question for you. And you're going to answer that question. And depending on if you get it right or wrong, it's going to say, all right, you got that wrong. You get 0 points. Or you got that right. This is how many points that you get. Stuff like that. If you get a certain amount of points right, you'll actually win the game. You get a certain amount of points wrong, you'll actually lose the game automatically. So that being said, every 3 places they visit will actually be a year. So after they visit 3 places, we'll be like, okay, that was the end of this year. This is everything that you've done. This is how that worked. And that's how you win or lose the game. Automatically, if you get a certain amount